So let's go ahead and go down the negative part first, because that's actually the more complicated one. Let's just get it over with, all right? So the second question that I ask myself, once I've determined that it's negative, oh, by the way, I'm sorry, there's something that I forgot to tell you guys. There's going to be some negative nucleophiles that don't look negative at the beginning, okay? And that's because they're attached to a spectator ion. Do you guys remember what spectator ions are? They're just ions that dissociate in solution and don't participate in the reaction. So spectator ions, there's actually 4 of them. They're in the first column of the periodic table, and there's 4 that you should be aware of. We have lithium, okay? Lithium dissociates into Li positive. We have sodium. We have potassium. And then finally we have cesium, which doesn't always show up, but sometimes it does, okay? These are the 4 cations that are going to dissociate from our nucleophiles and make them negatively charged. So for example, if I gave you, I'm just going to tell you this is a really common mistake that's made. If I gave you the nucleophile NaOH, guess what's going to happen? A lot of students are going to say that's neutral. But obviously that's not neutral, right? You have to dissociate the Na first, and what you're going to get afterwards is OH minus. That is negatively charged, so you go down the left-hand side. Do you guys see how to use that? So watch out for these spectators, okay? They're there to make your life just a little bit more complicated. Now let's go to the second question. The second question I ask myself is, okay, I know that I have a nucleophile that's negatively charged. I know it's strong, but is it a bulky base, okay? And for this question, we're just going to memorize 3 bulky bases, all right? These are just 3 bulky bases that I've seen professors use. There really isn't a very long list of them, okay? So really, if you just memorize this list of 3, you're set. And all it is tert butoxide, which is this one, LDA, and LITMP. These are the 3 bulky bases that you could find. And what you might even notice is that your professor might not use all 3, okay? A lot of times professors will have like a pet base that they really like, and they'll just stick with it the whole semester. So for example, some professors love LDA. They're just LDA everywhere. Some professors love tert butoxide everywhere. It just depends on which professor you get. So I would just say just know them just in case. Also, in case you ever want to look up this stuff online or do some more reading in your book, you want to know what the other ones are, even though your professor might not use it very often. Cool. So those are the 3 that we say they're bulky. And if they're bulky, what did we say about nucleophiles? If I have a very bulky nucleophile, is that going to be a good base or a bad base? That's going to be a really good base. Remember that I said that bulk increases basicity. So that means that automatically, right away, we know what the mechanism is. We know that it's going to be a really strong base, so it's going to be E2. Isn't that easy? We're just going to say, oh, this is E2 right away. Now, notice that it has a word Hoffman next to it. Don't worry about that yet. We haven't gotten there yet. This flowchart not only works for this topic, but it works later on as well. So we're going to get there in a little bit. So that would be if we said yes, that it is bulky. Okay, now, but what if it's no? What if, like, for example, OH negative, is that one of the 3 bulky bases? No, it's not. So that means I keep going to now the next question. The next question is question 3. So you can see we've already asked ourselves 2 questions. We're on to the third one. The third one is, what type of leaving group do I have? Okay, so remember that leaving group could be a few different things. Usually, that's going to be an alkyl halide, but that could also be a sulfonate ester, right? Okay. And then we also said water, but yeah, water too, sure. So it could also be water, but water doesn't happen quite as much. So I'm just going to put here. Okay, so those are like our 3 main leaving groups. So now the way that we have to think about these leaving groups is we want to separate them into 2 categories. There's the leaving groups that have a good backside. That means they're really accessible. It's easy to do a backside attack. And then we have the nucleophiles that have a bad backside. So if you had to think about the types of nucleophiles that have a really good backside, what would you think? What would you say? Very available, very down for backside attack. That would be methyl and primary, right? Because they're like have no steric bulk back there. So it turns out that methyl and primary are always going to pretty much give us the same mechanism because they have a good, I'm just going to write it here, good backside. Okay, so we get an SN2 reaction. Everything that went along with SN2, you think of it, that's going to be for methyl and for primary. Easy, right? But now we think about the secondary and tertiaries. The secondary and the tertiaries, which are right here and here, are the ones with bad backsides. Okay? They aren't as good. In fact, tertiary is impossible. Secondary can happen, but it's kind of bad at some cases. So for secondary and tertiary, we're going to have to ask ourselves another question. So this brings us to the fourth question. Let's start off with secondary first. Okay? So now for secondary, what I want to ask myself is, okay, this nucleophile it's negatively charged, it's not bulky. What I want to know is it going to be a better nucleophile? Is it going to be better at donating electrons? Or is it going to be a better base, meaning that it's better at pulling off protons? Okay? For this part, all I want you to do is memorize the good bases. Why? Because it turns out that there's probably 20 different nucleophiles that your professor could use. Okay? Lots of different ones. He could basically put anything with a negative charge on it and say that's a nucleophile. Okay? And for you as a student, that could get very confusing trying to memorize every single nucleophile and what it does. Okay? So instead of memorizing every single nucleophile, let's just memorize the ones that are good bases, because that's a much shorter list. And then what that means is that anything that's not on my base list, I'm going to automatically assume is better at a nucleophile, being a nucleophile. So what are these bases that are strong bases? The bases are, 1, oxides. That means any molecule that I have OR negative. Okay? So that's the first one. The second one is called an alkanide. An alkanide is just a triple bond with a negative charge at one side. Okay? That negative charge has to be directly on the C. That's also a very, very strong base. It's not very stable. Okay? Then we have two bases that are very similar, which is NH2 negative and H negative. These are both going to be small, very strong bases because they're not very stable in solution at all. And then finally, we have one more thing that's not really a base, but it favors basic reactions, and that's heat. Okay? It turns out that heat is going to favor elimination for a variety of reasons. Okay? So these 5 things are the things that I want you guys to memorize as favoring an E2 mechanism on a secondary alkyl halide. Okay? If you have one of those 5 things, or even more than one of those 5 things, then for sure it's going to be E2. Now, what's this word next to it, Zaitsev? Again, don't worry about that. We're not going to get to that until the next topic, okay? Or until a few topics from now, okay? But for right now, you should just know that it's E2. All right? So now, what if I gave you a nucleophile that you really don't know what it is? For example, if I gave you something that looks like this. N, double bond N, positive, negative. All right? So what if I gave you a nucleophile that looks like that? Okay? Oh, I'm sorry. This is supposed to be a negative 2. So then after you, just so you know, this is actually called N3 negative. Okay? If you added up all the formal charges, it would be negative at the end. And I gave you N3 negative on a secondary alkyl halide. Okay? So my question to you is, what would the nucleophile be? I mean, what would the mechanism be? And I would just ask myself, okay, is N3 negative on my base list? Is it an oxide? No. Is it an alkanide? No. No, no, no. There's no heat. So that means it must be in my nucleophile category, that it's not a good base, and that's going to be SN2. And that's going to apply for a lot of different nucleophiles. So also, like, for example, SH negative, okay? SH negative, not on this list, right? So that means it must be a better nucleophile, and it's going to do SN2. Do you guys get the point? Okay? So basically, I'm just going to go with whatever those bases are, that's E2. If it's not on that list, it's going to prefer SN2. All right? Are you guys cool with that? Awesome. So now let's go to tertiary. So for tertiary, So for tertiary, we get a similar problem where we need to figure out if it's a nucleophile or a base. So now for the base list, it's actually going to be the same as the other list, so the same 5 compounds, except that now I'm going to add OH negative to the mix. Okay, so OH negative was actually not on my list before, because my list before as strong bases, it only had oxides. OH negative is not an oxide because it doesn't have an R group attached to the O. That's a hydroxyl. It's hydroxide. It's not an oxide. So, but now I'm going to treat the hydroxide as one of the strong bases. So it's actually going to be those 5 things I told you plus OH negative are going to favor E2. Okay?